dear students, welcome to Scientia. Today I am going to explain you about atom, molecule and atomic mass. These all are the very basic concepts of the chemistry. Without knowing this, understanding more concepts or any other concepts in the chemistry will be very difficult. So, let's get started. What is an atom? Atom is the smallest particle of matter which participate in chemical reaction and does not loses its identity. That means atom is the smallest particle of matter. That is the first point. Atom is the smallest particle of matter. Second, it should participate in chemical reaction. Third point, it does not loses its identity. Any substance we cannot say it is an atom. If we want to say something is an atom, it should participate in chemical reaction and it does not loses its identity. It is very important, children. If we want to say something is an atom, it should participate in chemical reaction and does not loses its identity. If we want to say hydrogen is an atom, it should participate in chemical reaction. For example, hydrogen is combining with oxygen and we will get water molecule. If I want to say hydrogen is an atom, it should participate in chemical reaction. Otherwise, I cannot say. So, first point, it should participate in the chemical reaction. Second point, it does not loses its identity. What does it mean? See children, in this reaction, before the reaction, hydrogen is existing as hydrogen here. After the reaction also, in the water molecule, hydrogen existing as a hydrogen. The hydrogen is not changing into nitrogen. That means it does not loses its identity. We can take another example. Carbon is combining with oxygen and we will get carbon dioxide molecule. Here, before the reaction, carbon existing as carbon. After the reaction also in carbon dioxide, it existing as carbon. This carbon is not converting into sulfur. That means the carbon identity does not change. That means we can say carbon is an atom. So, if we want to say something is an atom, it should participate in the chemical reaction and it does not loses its identity. Then the next point, atom have no independent existence. That means a single atom you cannot find. Atom is always existing as a combined state. For example, if you take hydrogen atom, you cannot find a single hydrogen atom. It always existing as H2. You cannot see a single oxygen atom. It always existing as O2. You cannot find a single nitrogen atom. It always existing as N2. That means you cannot find a single atom in the universe. It always exists as a combined state. Here hydrogen is bonding with hydrogen. Here oxygen is bonding with another oxygen. Hydrogen is always combined with another nitrogen atom and it existing as N2. You may have a question now. Then what is the case of ion? See children, we will always say ion as a block. In this ion piece, there are many ion atoms. It is bonded with metallic bonding with another ion and it always existing as a block. So in this case also, there is no single atom is existing. It always existing as a combined state. So what is an atom? Atom is the smallest particle of matter. It should participate in chemical reaction. It does not loses its identity and atom have no independent existence. So if we want to say hydrogen is an atom, it should be fulfill all the four conditions. If we want to say nitrogen is an atom, it should fulfill all the four conditions. If we want to say carbon is an atom, it has to be satisfied all the four conditions. Now let's move to molecule. Molecule is the smallest particle of matter which exists independently. That means independent existing of the molecule is possible. So, molecule is the smallest particle of matter which exists independently. That means if you take a water molecule, it can exist independently. If you take carbon dioxide molecule, it can exist independently. So, only one difference, the atom is the smallest particle of matter which cannot exist independently, while the molecule is the smallest particle of the matter which exists independently. Before going to the topic atomic mass, you just listen to me. Assume that I have an elephant, goat and a hen, and I'm living years back where there is no sophisticated devices to find the weight of these animals. So I'm going to take a stone and comparing the weight. So I have a stone here and I placed elephant in one side and I placed 1,000 stones. Now it's balanced. Then I place goat in a balancing machine and I kept 40 stones. And I placed hen over there and I placed around 5 stones. Every time I'm writing here stones. So I considered this stone as a unit and I say kg. So I'm replacing all these stones and mentioning here kg instead of stones. So I can say the weight of the elephant 1000 kg, goat 40 kg, hen 5 kg. Like that, you just imagine I want to find the weight of nitrogen atom, sodium atom or oxygen atom. So like stone, I made a unit. I took 1/12 of mass of one carbon 12 atom as a standard. So I place 14 times of 1/12 mass of one carbon 12 atom and the nitrogen atoms is balanced. Like that, I place 23 1/12 of mass of one carbon 12 atom and the weight is balanced. Like that, if I place 16 times 1/12 of mass of one carbon 12 atom, the oxygen atom is balanced. So, see children, every time I want to write 1/12 of mass of one carbon 12 atom like that. So, what I did know, this 1/12 of mass of one carbon 12 atom, I called it as a 1 atomic mass unit. That means 1 atomic mass unit, 1 AMU, is equal to 1/12 of mass of one carbon 12 atom. This you always have to keep in mind. So see children, every time I want to write nitrogen equal to 14, 1/12 of mass of carbon 12 atom like that. So instead of that, I'm writing AMU. That means Nitrogen is equal to 14 AMU. Sodium atom is equal to 23 AMU. Oxygen atom is equal to 16 AMU. 1 AMU is equal to 1 by 12th of mass of 1 carbon-12 atom. Years after, scientists found out with the help of mass spectrometer the mass of 1 carbon-12 atom. So, that is equal to mass of 1 carbon-12 atom is equal to 1.99 into 10 to the power minus 23 gram. So, 1 AMU is equal to 1 by 12th of 1 by 1.99 into 10 to the power minus 23 gram, which is equal to 1.66 into 10 to the power minus 24 gram, which is equal to reciprocal of Avogadro number. This is very important. Here, weight of one nitrogen atom is equal to 14 AMU. Instead of that, I can write 14 divided by Na gram. 14 divided by Na gram, because 1 AMU is equal to 1 by Na gram. 1 AMU is equal to 1 by Na gram. So, I can also write 1 nitrogen atom is equal to 14 by Na gram. 1 oxygen atom is equal to 16 by Na gram. Weight of 1 sodium atom is equal to 23 into 1 by Na gram. So children, always you have to keep in mind, these all are weight of one single sodium atom, weight of one single oxygen atom, weight of one single nitrogen atom. Finally, atomic mass is a number which tells that how many times an atom of an element is heavier than 1 by 12th mass of carbon-12 atom. For example, 1 sodium atom is equal to 14 times heavier than 1 by 12th mass of 1 carbon-12 atom. 1 oxygen atom is equal to 16 times heavier than 1 by 12th mass of carbon-12 atom. So, the definition of atomic mass is an element how many times heavier than 1 by 12th mass of carbon-12 atom. I hope all you clear this.